So continuing in chapter 14b, we're going to look at example 7, where we're using angle difference identity here. I know I'm using my angle difference identity because I'm told I need to in the question. I'm going to use my angle difference identity here, but instead of being given an angle or trying to find an angle, I'm told values for cos A and cos B. So let's just write out our angle difference identity. That is going to be sine of A minus B is equal to sine A cos B minus cos A sine B. So I've got my identity here. I know that cos A is equal to 3/5, and I know cos B is equal to 12/13. Now I don't know sine A, and I don't know sine B. However, I kind of said before, if we're trying to figure out cos and I know sine, we do have an identity that links them, and that is my Pythagorean identity, which says that, hey, sine, in this case, our angle is A, so let's use A. Sine squared A plus cos squared A is equal to 1. Now, I know what, if I do for sine A, if I do cos A, that's going to become sine squared A plus 3/5 squared equals 1. And now I've kind of created a problem that's a little bit similar to something I did kind of earlier in, I think it would have been 14a. I'm going to use that idea to help me solve for sine A. So again, I'm going to subtract 3/5 squared off each side. Sine squared A is going to equal 1 minus 9 over 25, which is going to equal 16 over 25. So that means that sine A is going to equal the square root of 16 over 25, which is going to equal 4/5. I should write plus or minus 4/5, and I should put plus or minus here. However, if I go back and read the question, it did tell me that, it told me that A and B are acute angles. If they're acute angles, an acute angle is less than 90, so it must be just positive 4/5, because it must be in my first quadrant. So I'm going to just get rid of my plus or minus for my solution. So I found sine A. I'm now going to do the exact same process to find sine B. So I have jumped ahead a little bit, and I've kind of filled in some of the working out that's exactly the same as the first example. Once I'm here, square at the top, square at the bottom, and I'm going to get sine B is equal to 5/13. So I've got my two values. Again, it has to be positive because my angles are acute, which means now I'm going to put this back into my angle difference identity to find sine A minus B. Is going to be equal to 4/5 times 12/13 minus 3/5 times 5/13. Let me just make sure my numbers are correct. Perfect. So now 5/12 are 60, so 5/13 are going to be 65, and then 4 times 12 is going to be 48. So it's going to be 48 over 65 minus 15 over 65, which is going to equal 33 over 65. Now, just a little bit of an interesting wrinkle about this solution is that I actually still don't know my angles, and I don't necessarily need to know my angles for a question like this, because I just want to find my angle difference. So sine A minus B is equal to 33 on 65.